Hey y'all, it's Miss Flores. So today we're going to be discussing divisibility rules. So divisibility rules are basically rules that we follow in order to determine if a number is divisible by another number. So in order for divisibility rules to apply, a number is divisible by another number if it will divide evenly with no remainder. So any numbers that I divide and I end up having a remainder, that's not what we're dealing with right now. We're only talking about numbers that go in evenly, completely, nothing left over, nothing like that. So we are going to be discussing the divisibility rules for these particular numbers today. So we're going to go over 2, 3, 5, 6, 9, and 10. So there are rules that we can use to determine if a number is divisible by 2, 3, 5, 6, 9, and 10. So let's look at our rule for 2 first. Alright, so our rule for 2 is that all even numbers are divisible by 2. So any number that ends with a 2, 4, 6, 8, or 0, so it has a 2, 4, 6, 8, or 0 in the ones place, is going to be an even number, which means that it is divisible by 2. So let's look at these numbers. What of these numbers are divisible by 2? So remember, I need it to have a 2, 4, 6, 8, or 0 in the ones place. So in the ones place of 12, I've got a 2. So that would make 12 even, so it would be divisible by 2. 338. I have an 8 in the ones place. So remember, it's 2, 4, 6, 8, or 0, which means that 338 is even, so it would be divisible by 2. 572. It needs to have a 2, 4, 6, 8, or 0 in the ones place. It has a 2, so that means it would be even, so it would be divisible by 2. 43. It has a 3 in the ones place. Remember, it needed to have a 2, 4, 6, 8, or 0. 43 is not even, so it would not be able to be divisible by 2. 790. Remember, 2, 4, 6, 8, or 0 in the ones place. It has a 0, which means that it's even, so it would be able to be divisible by 2. And then 241. It has a 1 in the ones place. It needed to have a 2, 4, 6, 8, or 0 in the ones place, so it is not even, so it would not be able to be divided by 2. So only our four numbers 12, 338, 572, and 790 are even numbers, so they would only be the ones that would be divisible by 2. Let's look at our next one. Our rule for 3. For our rule for 3, you need to add the digits in the number, and if their sum is a multiple of 3, then the number is divisible by 3. So let's look at this. Our example is 345. So I'm going to add their digits. So I have my digits would be 3 plus 4 plus 5. Well, 3 plus 4 is 7, plus 5 is 12. So my digits would be 12. So if 12 is not a multiple of, 12 is a multiple of 3. I don't know what I'm saying. So 12 is a multiple of 3, right? If I skip count by 3, I have 3, 6, 9, 12. So 12 is a multiple of 3. So that means 345 would be a number that could be divided by 3. Sorry, y'all. I was thinking about the rules for 9 for a second. But that is the rule for 3. If my digits add up to be a multiple of 3, then my whole number is divisible by 3. So let's look at our examples. So we're going to know which of the following are divisible by 3. So I'm going to add up all of my digits. So I'm going to do 5 plus 1 plus 4 plus 2. Well, 5 plus 1 is 6, plus 4 is 10, plus 2 is 12. So they add up to be 12. My multiples of 3 were 3, 6, 9, 12. So 12 is a multiple of 3, which means 5,142 would be divisible by 3. Let's try 809. So I'm going to add 8 plus 0 plus 9. Well, 8 plus 0 is 8, plus 9 is 17. So skip count by 3. Those are my multiples. So I've had 3, 6, 9, 12, 15, 18. 17 isn't in there. So 809 would not be a multiple of, or would not be able to be divisible by 3. Let's try 63. So I'm going to add 6 plus 3. 6 plus 3 is 9. So if I skip count by 3, if I run into 9, then my 63 is divisible by 3. So 3, 6, 9. So 9 is a multiple of 3, which means 63 is divisible by 3. Now let's try 1,330. I have 1 plus 3 plus 3 plus 0. Well, 1 plus 3 is 4, plus 3 is 7, plus 0 is still 7. So let's skip count by 3. 3, 6, 9. I don't run into 7. So that means 1,330 is not divisible by 3. So let's try my rule for 5. A number is divisible by 5 if there is a 0 or 5 in the ones place. So that's pretty easy. It's kind of like a rule for 2. Let's look at our examples. So we're going to know which of the following are divisible by 5. Well, we need to have a 0 or a 5 in the ones place. 390 has a 0 in the ones place, so that means 390 is divisible by 5. 558 has an 8 in the ones place. It needed to be a 0 or a 5, so 558 is not divisible by 5. 65 has a 5 in the ones place. It needed a 0 or a 5, so it is divisible by 5. And then 1,265 has a 5 in the ones place. It needed a 0 or a 5, so it is also divisible by 5. So 390, 65, and 1,265 are all divisible by 5. All right, let's look at our rule for 6. So a number is divisible by 6 if the number is divisible by 2 and 3. So the number must be even and the digits must add up to be a sum that is a multiple of 3. So for 6, it has to follow the rules for 2 and 3. So not only does it have to be an even number, but I also need to check that my digits add up to be a multiple of 3. So let's see about these problems. So I've got 32, 40, 7, 1,986, 66, and 40. So let's check first with our even numbers. So for a number to be even, it has to end in a 2, 4, 6, 8, or 0 in the ones place. Well, 32 has a 2 in the ones place, so that's good so far. 40 has a 0 in the ones place, so that's even so far. 7 has a 7 in the ones place. It needed to be 2, 4, 6, 8, or 0. So 7 won't work because it's not even. 1,986 has a 6 in the ones place, so that's even. 66 has a 6 in the ones place, so that's even. 40 has a 0 in the ones place, so that is also even. So we were able to eliminate one of them because it was not an even number. So now, let's add our digits to see if they're a multiple of 3. And if they are, that means that the number is even and divisible by 3, so it would be divisible by 6. So 32 would be 3 plus 2. 3 plus 2 is 5. If I skip count by 3, that's 3, 6, 9, 5 isn't in there. So 32 would not be divisible by 3, so that means it wouldn't be divisible by 6 either. 40 would be 4 plus 0. So 4 plus 0 is 4. If I skip count by 3, I've got 3, 6, 9, 4 is not in there. So 40 would not be divisible by 3, so it won't be divisible by 6. Oop, I realized there's two 40s. So neither 40 would be divisible by 6. So let's try 1,986. So I'm going to do 1 plus 9 plus 8 plus 6. So 1 plus 9 is 10, plus 8 is 18, plus 6 is 24. So let's skip count by 3. 3, 6, 9, 12, 15, 18, 21, 24. So 24 is a multiple of 3, which means that it's divisible by 3, and it's divisible by 2, which means that it is divisible by 6. Let's try 66. I've got 6 plus 6 6 plus 6 is 12. So let's give count by 3. 3, 6, 9, 12. So 12 is a multiple of 3, which means 66 is divisible by 3. So since it's divisible by 3 and 2, it is divisible by 6. So the only two numbers that were divisible by 6 were 1,986 and 66. Let's look at our rule for 9. The rule for 9 is similar to the rule of 3. I need to add all of my digits, and if my sum is a multiple of 9, then that means it is divisible by 9. So let's try to add them up. I've got 3 plus 4 plus 2 for 342. Well, 3 plus 4 is 7, plus 2 is 9. Well, if I skip count by 9, 9 is the first number I run into, right? So 9 is a multiple of 9, which means 342 is divisible by 9. Also, fun fact, if it is divisible by 9, it's also always going to be divisible by 3. So let's look at some examples for 9. Alright, so same kind of idea as 3. I'm going to add up all my numbers, and if it is a multiple of 9, then it is divisible by 9. So I'm going to do 1 plus 9 plus 8 for 198. So 1 plus 9 is 10, plus 8 is 18. So let's skip count by 9. 9, 18. 18 is a multiple of 9, so 198 would be divisible by 9. Let's try 62. So I'll do 6 plus 2. 6 plus 2 is 8. If I skip count by 9, 9, 18, 27, 8's not on there. So 62 would not be divisible by 9. Let's try 914. So 9 plus 1 plus 4. 9 plus 1 is 10, plus 4 is 14. If I skip count by 9, I run into 9, 18, 27, 14's not there. So 914 would not be a multiple of 9. Or 914 would not be divisible by 9. So let's try 5,877. So I'll do 5 plus 8 plus 7 plus 7. 5 plus 8 is 13, plus 7 is 20, plus another 7 is 27. So let's skip count by 9. 9, 18, 27. 27 is a multiple of 9, so 5,877 would be able to be divided by 9 evenly. Let's try 54. I'll do 5 plus 4. 5 plus 4 is 9. Well, 9 is a multiple of 9, right? So that means 54 would be able to be evenly divided by 9. Now let's try 378. So we've got 3 plus 7 plus 8. Well, 3 plus 7 is 10. Plus 8 is 18. So if I skip count by 9, 9, 18. 18 is a multiple of 9, so that means 378 would be able to be divided evenly by 9. So let's try our last rule. Our last rule is for 10. The rule for 10 is super easy. Any number that has a 0 in the ones place is divisible by 10. So let's look. I've got 405, 1,008, 70, 1,230, and 590. Well, we're looking for a 0 in the one spot. That's a 5, so that would not be able to be divided by 10. 1,008 has an 8 in the ones and needs a 0, so that wouldn't be divisible by 10. 70 has a 0 in the one spot, so 70 would be able to be evenly divided by 10. 1,230 has a 0 in the ones, so it would be able to evenly be divisible by 10. And 590 also has a 0 in the ones, so it would be able to be divided by 10. All right, y'all, here is your assignment for today. So you've got a Google slide divisibility practice. So you're going to fill in the table on slide 3 using your divisibility rules from today's video lesson. There's also a PDF copy of the divisibility rules for you to reference in the activity for you to use later on. Then we're going to do an example together on slide 2 of how to fill out the table. So here is our example. All right, so we have our number 204. So the first part of our problem is we're going to do the digit sum. So that's where we add up all of our digits to see if it's divisible by 3, 6, or 9. So in this case, my numbers are 2 plus 0 plus 4. Well, 2 plus 0 is 2, plus 4 is 6. So that would be my digit sum. Remember, for a number to be divisible by 6, it needs to be divisible by 2 and 3. So first off, let's look at 2. For a number to be divisible by 2, it has to be even. For it to be even, it needs to end in 2, 4, 6, 8, or 0. Well, it ends in a 4, so it means it's an even number. So I'm going to put an X, just a big capital X, to show that it is divisible by 2. For it to be divisible by 3, it needs to be a multiple of 3. Well, if I skip count by 3, my digit sum needed to be a multiple of 3, right? So 3, 6. It does have a digit sum of 6, which means it would be divisible by 3. For it to be divisible by 5, it needs to have a 5 or a 0 in the ones place. It has a 4, so it's not going to be divisible by 5. For it to be divisible by 6, it has to be divisible by 2 and 3. Well, I already checked off that it was divisible by 2 and 3. So it is going to be divisible by 6. For it to be divisible by 9, that's kind of like the rules for 3, but it needs to add up to be a multiple of 9. Well, my digits don't add up to be a multiple of 9, right? 6 is not quite a multiple of 9, so that's not going to work. And then for it to be divisible by 10, it needs to have a 0 in the ones place. It has a 4 in the ones place, so that's not going to work either. So now my final step is to type the numbers that they are divisible by. Well, I said that it was divisible by 2, and that it was divisible by 3, and that it was divisible by 6. So that's how you're going to fill out all of your boxes. So let's look at our final table. This is our table. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that y'all are going to do. Let's do 16 though as another example. So let's type our digit sum here. Our digit sum is going to be the sum of our digits, right? So I'm going to do 1 plus 6. Well, 1 plus 6 is equal to 7. So let's see if that helps us later. All right, for our number to be divisible by 2, it needs to have be an even number. So it needs to end in 2, 4, 6, 8, or 0. Well, 16 ends in 6, so it would be even. So it is going to be divisible by 2. For our number to be divisible by 3, my digit sum had to be a multiple of 3. So if I skip count by 3, let's see if I run into 7. 3, 6, 9. I don't run into 7, so it's not going to be divisible by 3. Let's see if it is divisible by 5. If it's divisible by 5, it would have a 5 or a 0 in the ones place. Well, it has a 6, so it's not going to be divisible by 5. For it to be divisible by 6, it needs to meet the rules for 2 and 3. So it needs to be divisible by 2 and 3. Well, it was only divisible by 2. It wasn't quite divisible by 3. So it's not going to be divisible by 6. Our rule for 9 was that our digit sum had to add up to be a multiple of 9. 7 is not a multiple of 9, so it's not going to be divisible by 9. And then for it to be divisible by 10, I need to have a 0 in the ones place. It had a 6 in the ones place, so it's not going to be divisible by 10. So the numbers that my 16 is divisible by is only going to be 2 in this case. So sometimes numbers are only divisible by one number. Sometimes they're divisible by multiple numbers, right? Just like in our example before, 204 was divisible by 2, 3, and 6. 16 was only divisible by 2. So make sure that you're checking the rules for all to figure out if it's divisible by 2, 3, 5, 6, 9, and 10, because you don't want it to just be divisible by one number if it's divisible by more than that, right? So you're going to do the rest of these on your own, and then when we meet back up later today, we'll go over some of them. We probably won't have time for all, but we'll go over some of them together. All right, guys, let me know if y'all have any questions in the comments section of this assignment, and I will talk to y'all later. Bye, guys. Have a good day.